Welcome to the quiet hours of curiosity, where we tell the stories that shaped us long before we had words to tell them ourselves. Whether you're here to drift off to sleep, focus on work, or simply let your mind wander through deep time, you've found the right place. This is where we explore the slow, patient forces that carved humanity into what we are today. Welcome back to Sleepless Homo Sapien. If this kind of thoughtful, evidence-based storytelling helps you learn something new, or simply provides a calm companion for your evening, consider subscribing. It's a small gesture that helps more curious minds discover this space for long-form, science-grounded exploration. No rushed conclusions, no wild speculation, just the humble attempt to understand our ancestors through what they left behind. And if you drift off at some point, no worries at all. There are timestamps in the description, so tomorrow you can pick up exactly where the ice and time left off. Now let's step back, way back, to a world so cold and strange that if you could visit it, you might not recognize Earth at all. Imagine standing on what is now the coast of New York, but instead of skyscrapers piercing the sky, there's a wall of ice stretching higher than you can see, a glacier thick as a mountain laid sideways, grinding slowly southward, carrying boulders the size of houses like they were pebbles. The ocean is 300 feet lower than it is today. You could walk from England to France without getting your feet wet. Siberia and Alaska are connected by a bridge of frozen land wider than Texas. This is Earth during the last glacial maximum, roughly 20,000 years ago. And somewhere in this alien landscape, small bands of humans are not just surviving, they're adapting in ways that would fundamentally alter the trajectory of our species. Because what we're about to explore isn't just how ice shaped the land, it's how ice shaped us. The story begins long before the glaciers reached their peak. Around 70,000 years ago, Earth's climate began its slow descent into one of the most severe ice ages our planet has ever known. But this wasn't a sudden freeze. Climate doesn't work that way. Instead, it was a gradual tightening, a planetary breath held for millennia, as temperatures dropped and ice began to claim more and more of the northern continents. The mechanics are elegant in their simplicity. Earth's orbit around the Sun isn't perfectly circular, and our planet's tilt shifts over tens of thousands of years. These tiny astronomical wobbles, called Milankovitch cycles, determine how much sunlight reaches different parts of Earth during different seasons. When the northern hemisphere receives less summer sunshine, snow that falls in winter doesn't fully melt. Year after year, it accumulates. Compacts, becomes ice, and ice, once it starts growing, feeds on itself. Here's why. Fresh snow reflects about 90% of the sun's energy back into space, but dark soil and vegetation absorb that same energy as heat. So as ice sheets expand, they create their own cooling effect, reflecting more sunlight away from Earth's surface. The planet grows colder, which allows the ice to spread further, which reflects even more sunlight. It's a feedback loop that can transform a planet. By the time we reach the last glacial maximum around 20,000 years ago, ice sheets covered most of Canada, reached down into what is now the northern United States, and stretched across Scandinavia and northern Russia. These weren't just thick patches of snow. These were ice sheets, over a mile thick in places, so heavy they pressed the very continents down into the Earth's mantle. But the ice was only part of the story. As water became locked up in these massive glaciers, sea levels dropped dramatically. Coastlines that had been underwater for millions of years suddenly became dry land. The Bering Land Bridge emerged, connecting Asia and North America. The English Channel vanished, making Britain part of continental Europe. Indonesia became a single massive continent called Sunda Australia, and New Guinea merged into one landmass. For the humans living through this transformation, the world was becoming both smaller and larger at the same time. Smaller because oceans that had once separated continents were now crossable on foot. Larger because vast new territories were opening up, landscapes that had never felt human footsteps. But this wasn't a world of endless opportunity. It was a world of brutal selection pressure. And that pressure was about to forge our species in ways we're only beginning to understand. The human populations that entered this ice age were already remarkable. They had mastered fire, developed complex tools, created art, and spread across Africa and into Asia. But the ice age would test every adaptation they had developed and demand new ones they had never needed before. First came the cold itself, not just winter cold, but cold that lasted for generations. Average global temperatures dropped by about 10 degrees Celsius. In the regions closest to the ice sheets, temperatures plummeted even further. This wasn't weather you could simply wait out. This was climate you had to adapt to or die. The archaeological record from this period tells a story of innovation driven by necessity. In what is now the Czech Republic, at a site called Dolní Věstonice, humans 26,000 years ago were building shelters using mammoth bones as structural supports, covering them with hides and sod for insulation. These weren't crude lean-tos, they were engineered dwellings designed to hold heat and withstand months of sub-zero temperatures. The tools changed too. Stone blades became longer, thinner, more efficient. Composite tools appeared, with multiple materials bound together to create implements more effective than anything made from a single material. Atlatls, or spear throwers, gave hunters greater range and power. Bone needles allowed for the creation of fitted clothing, crucial for survival in extreme cold. But perhaps most importantly, social structures began to evolve. The small family groups that had characterized earlier human societies began to form larger, more complex networks. Trade routes emerged, carrying high-quality stone and other materials across hundreds of miles. At Sungir in Russia, burials from 28,000 years ago show children interred with thousands of mammoth ivory beads, suggesting not just individual wealth, but community investment in symbolic display. This social complexity wasn't luxury, it was survival strategy. In a world where resources were scarce and unpredictable, having relationships with distant groups could mean the difference between starvation and sustenance. Information networks became as important as tool networks. Knowing where the herds were, which routes were passable, where fresh water could be found, these weren't just advantages. They were lifelines. The Ice Age also created new ecological niches that humans learned to exploit. The Mammoth Steppe, a cold grassland ecosystem that stretched from Western Europe to eastern Siberia and into Alaska, supported massive herds of megafauna. Mammoths, woolly rhinoceros, giant bison, cave bears. These weren't just occasional hunting targets. For some human groups, they became the foundation of entire cultures. Evidence from sites like Mezherish in Ukraine shows that humans weren't just hunting these massive animals, they were organising their entire seasonal cycles around them. The bones weren't just meat, they were building materials, fuel, tools. Mammoth fat provided light and heat. Mammoth hide became shelter and clothing. Even mammoth dung, dried and stored, served as fuel when wood was scarce. But this specialisation came with risks. When you build your entire way of life around mammoth hunting, what happens when the mammoths disappear? That question would become urgent as the Ice Age progressed, because the same climate pressures that were shaping human culture were also driving evolutionary changes in the animals they depended on, and in the humans themselves. The genetic evidence from this period reveals something remarkable. The extreme conditions of the Ice Age created what population geneticists call bottleneck effects. Small isolated groups of humans faced environmental pressures so severe that only those with certain genetic advantages survived to reproduce. Some of these adaptations are still with us today. Populations that lived in northern latitudes developed genetic variants that improved their ability to produce vitamin D from limited sunlight. Others evolved better cold tolerance, more efficient metabolism, or enhanced immune responses to the diseases that thrived in crowded winter shelters. But the most profound changes weren't necessarily genetic. They were cultural, because the Ice Age didn't just test individual survival, it tested the survival of information. In a world where the wrong decision could kill your entire group, the ability to accumulate, preserve, and transmit knowledge became perhaps the most important human adaptation of all. This is where the story becomes truly extraordinary, because as we'll see, the humans who emerged from the Ice Age weren't just survivors. They were carriers of something unprecedented in Earth's history. A form of evolution that operated not through genes alone, but through ideas, technologies, and social innovations that could be passed down and improved upon across generations. The mammoth hunters of Siberia were developing techniques for working ivory that wouldn't be matched until the Renaissance. The reindeer herders of northern Europe were creating astronomical calendars carved in bone. The cave artists of France and Spain were producing works of such sophistication that when they were first discovered, many scientists refused to believe they were ancient. Something was happening to the human mind during the Ice Age, something that would prove far more important than any physical adaptation. But to understand what that was, we need to look more closely at how these scattered bands of Ice Age humans were actually living, day by day, season by season, in a world that was colder and stranger than anything we can easily imagine today. And that's where our story really begins to get interesting, because the ice wasn't just changing the landscape, it was changing the very nature of what it meant to be human. The transformation wasn't visible from day to day. You couldn't wake up one morning and notice that your world had fundamentally shifted. But over the span of generations, something unprecedented was taking root in the scattered camps and shelters where humans huddled against the cold. The Ice Age wasn't just selecting for physical traits that could withstand the freeze, it was selecting for minds that could think their way through problems no human had ever faced before. Consider what daily life actually looked like for a band of hunters following reindeer herds across the tundra of what is now northern Germany 15,000 years ago. The sun barely rises above the horizon, casting everything in a perpetual twilight that lasts for months. The ground is frozen solid to depths that would require modern machinery to penetrate. Every calorie burned staying warm is a calorie that can't be used for hunting, gathering, or the endless maintenance that keeps primitive technology functional. In this environment, intelligence isn't just an advantage, it's the difference between your lineage continuing and your lineage ending in the snow. The archaeological sites from this period reveal just how sophisticated these solutions became. At Gunnersdorf in the Rhine Valley, dating to around 12,000 years ago, excavations have uncovered what can only be described as an outdoor workshop complex. Stone tool production areas are carefully separated from food processing zones. Bone and antler working stations are positioned to take advantage of the best light. Storage pits are dug at precise angles to prevent freezing while maintaining access. This wasn't random organisation, this was systematic thinking, applied to survival. Someone had figured out the optimal workflow for transforming raw materials into the tools that kept people alive, and then they had taught that system to others, who improved upon it and passed it on again. But the real revolution was happening inside human skulls. The constant pressure of Ice Age survival was rewarding a very specific type of thinking, the ability to model complex systems in your mind before committing resources to them in the real world. If you're planning a mammoth hunt, you can't afford to get it wrong. A single mistake means not just a failed hunt, but potentially the death of hunters who can't be replaced. So you have to think through every variable: wind direction and how it will affect scent, migration patterns and how they intersect with terrain, the behaviour of the herd when threatened, the coordination required among hunters, the tools needed for different phases of the hunt, the processing of meat that must happen quickly before it spoils or attracts scavengers. This kind of planning requires what cognitive scientists call working memory, the ability to hold multiple pieces of information in your mind simultaneously while manipulating them to solve problems. And the genetic evidence suggests that Ice Age humans were developing enhanced working memory capacity at an unprecedented rate. Studies of ancient DNA from European populations show that genes associated with brain development and neural connectivity were under strong positive selection during the Ice Age. Variants that improved cognitive flexibility, pattern recognition, and social learning were spreading through populations faster than random genetic drift could account for. Natural selection was literally reshaping the human brain. But genes alone don't explain what was happening, because the most remarkable innovations of the Ice Age weren't just technological, they were social, and they reveal a form of collective intelligence that may have been the most important evolutionary development in Earth's history. Take the phenomenon that archaeologists call the Magdalenian culture, which flourished across Western Europe between 17 and 12,000 years ago. These weren't isolated bands scraping out a subsistence existence. They were part of trade networks that stretched from the Atlantic coast to the Russian steppes. Amber from the Baltic Sea appears in caves in southern France. Flint from specific quarries in Belgium shows up in archaeological sites hundreds of miles away. Marine shells from the Mediterranean are found in inland settlements that had no direct access to the sea. This wasn't occasional contact. This was systematic exchange that required long-term planning, standardized measures of value, and sophisticated understanding of geography across vast distances. Someone had to figure out which materials were worth trading, how to transport them across dangerous terrain, and how to maintain relationships with groups they might only encounter once or twice a year. More remarkably, these trade networks seem to have been carrying more than just physical goods. They were carrying information. Tool technologies that originated in one region appear simultaneously across the entire network. Artistic styles spread faster than human migration could account for. Even specific hunting techniques show up in archaeological sites, separated by thousands of miles and connected only by these invisible threads of trade and communication. The Ice Age was creating the first truly global human culture. Not global in the sense of worldwide, but global in the sense of interconnected systems of knowledge and technology that transcended local environments and extended across entire continents. And this is where the story takes a turn that even the humans living through it couldn't have anticipated. Because around 15,000 years ago, the ice began to retreat. It didn't happen quickly. Climate change, even dramatic climate change, operates on timescales that make individual human lives seem brief. But for populations that had spent thousands of years adapting to Ice Age conditions, even gradual warming created cascading changes that rippled through every aspect of their existence. The megafauna that had supported entire cultures began to disappear, not all at once but steadily, as the ecosystems they depended on shifted and fragmented. The mammoth steppe, that vast grassland that had stretched across the northern continents, began breaking up into smaller patches, separated by forests and wetlands. The massive herds that had provided predictable sources of meat, bone and hide became smaller, more scattered, less reliable. For human populations that had built their entire way of life around hunting these animals, this presented an existential crisis. Do you follow the herds as they retreat northward into increasingly marginal territory? Do you adapt to hunting smaller, more dispersed game? Do you develop entirely new subsistence strategies? Different groups chose different solutions. Some followed the retreating ice, maintaining their traditional lifestyles for as long as possible. Archaeological sites in northern Scandinavia show that reindeer hunting cultures persisted there until relatively recent times, preserving Ice Age technologies and social structures long after they had disappeared elsewhere. But other populations made a choice that would reshape human history. Instead of following the herds or adapting to hunt different animals, they began to focus more intensively on plant resources, and not just gathering wild plants, but actively managing them, encouraging their growth, protecting them from competitors. This wasn't agriculture as we know it today. It was something subtler and perhaps more sophisticated. a form of landscape management that worked with natural systems rather than replacing them. Evidence from sites across the Middle East shows that humans were selectively harvesting wild grains, burning forests to encourage the growth of useful plants, and even transplanting species to locations where they would be more accessible. The cognitive skills that Ice Age humans had developed for tracking animals and coordinating hunts turned out to be perfectly suited for understanding plant ecology and managing complex agricultural systems. The working memory that allowed them to model mammoth behavior could just as easily model the interactions between different plant species. The social networks that had carried information about hunting grounds could carry information about growing seasons and soil management. But this transition wasn't just about food production, it was about a fundamental shift in humanity's relationship with the environment. For the first time in our species' history, humans weren't just adapting to their surroundings, they were actively reshaping those surroundings to better suit their needs. The psychological implications of this shift are staggering. When you can control your food supply, you can plan further into the future. When you can modify your environment, you begin to see yourself not as a part of nature, but as separate from it. When you can accumulate surplus resources, you can support individuals who specialize in activities other than food production. These changes were happening simultaneously across different parts of the world as the Ice Age ended. In the Middle East, wild wheat and barley were being domesticated. In China, rice cultivation was beginning. In the Americas, squash and beans were being selectively bred. In New Guinea, bananas and other tree crops were being managed in sophisticated agroforestry systems. The remarkable thing is that these developments were happening independently. There's no evidence that agricultural techniques were spreading from one region to another through trade or migration. Instead, human populations around the world were arriving at similar solutions to similar problems at roughly the same time. This suggests that the cognitive evolution that had occurred during the Ice Age had prepared our species for this transition. The enhanced working memory, pattern recognition, and social learning abilities that had been selected for during the coldest millennia were now being applied to entirely new challenges, and they were proving remarkably adaptable. But the transition out of the Ice Age also created new forms of selection pressure. Populations that successfully made the shift to food production could support larger communities, accumulate more resources, and develop more complex technologies. Those that couldn't were gradually displaced or absorbed. Within just a few thousand years, the mobile hunting bands that had characterized human society for hundreds of thousands of years were becoming increasingly rare. In their place were settled communities, then towns, then cities. The surplus food production that agriculture made possible supported craftsmen, priests, warriors, and eventually kings. The Ice Age had ended, but its legacy was just beginning to unfold. The cognitive adaptations that had allowed humans to survive the coldest period in our planet's recent history were now powering an explosion of cultural complexity that would transform Earth itself. And yet something was also being lost. The intimate knowledge of natural systems that had allowed Ice Age humans to thrive in the world's harshest environments was becoming less necessary as humans created increasingly artificial environments for themselves. The social networks that had once carried vital survival information were being replaced by hierarchical systems of control and authority. The end of the Ice Age marked not just a change in climate, but a fundamental transformation in what it meant to be human. We were becoming something new, something unprecedented in Earth's history. But whether that transformation represented progress or loss, gain or sacrifice, remains one of the most profound questions we face as a species. Because the humans who emerged from the Ice Age weren't just survivors of Earth's last great climate crisis. They were the architects of everything that would follow. The cities, the technologies, the art, the wars, the discoveries, the dreams, all of it flowed from the cognitive revolution that had taken place in the minds of our ancestors as they huddled around fires, crafted tools, and told stories through the longest, coldest night in human memory. The transformation wasn't immediate, and it wasn't uniform. Across the thawing landscapes of Europe, Asia, and the Americas, different human populations were experimenting with radically different approaches to survival in a warming world. Some clung to the old ways, following the retreating herds northward into the shrinking territories where Ice Age life could still persist. Others embraced change so completely that within a few generations their descendants would barely recognize the world their ancestors had known. But perhaps the most profound shift wasn't in what humans were doing. It was in how they were thinking about time itself. For hundreds of thousands of years, human consciousness had been shaped by the rhythms of immediate survival. You tracked animals that were present now. You gathered plants that were ripe today. You made tools for tasks you needed to accomplish this season. Even the most sophisticated Ice Age planning rarely extended beyond a single annual cycle. The end of the Ice Age changed that fundamental relationship with temporality. When you plant seeds, you're making a bet on a future that extends months into uncertainty. When you clear land and build permanent structures, you're committing not just yourself, but your children to a particular place and way of life. When you begin to accumulate surplus resources, you're creating the possibility of supporting people whose contributions won't be felt until years or even decades later. This expansion of temporal thinking had cascading effects throughout human societies. Language itself began to evolve new tenses, new ways of describing hypothetical futures and distant pasts. Oral traditions became more complex, carrying not just practical information, but elaborate genealogies, mythologies, and cosmologies that stretched back to the beginning of time and forward to imagined ends of the world. The archaeological evidence for this cognitive shift is subtle but unmistakable. At sites like Göbekli Tepe, in what is now Turkey, dating to around 11,000 years ago, we find massive stone circles that required coordinated labour from hundreds of people over multiple generations. These weren't practical structures in any immediate sense. They were investments in symbolic meaning that could only make sense to minds capable of thinking decades or centuries into the future. The artwork from this period tells a similar story. The naturalistic animal paintings that characterized Ice Age cave art began giving way to increasingly abstract symbols, geometric patterns, and representations of concepts rather than concrete objects. Human figures appear more frequently, but they're often stylized, ritualized, shown in contexts that seem more mythological than documentary. This shift toward abstraction wasn't just aesthetic, it reflected a fundamental change in how humans were categorizing and understanding their world. Instead of thinking primarily in terms of immediate sensory experience, they were developing mental models based on relationships, hierarchies, and systems that couldn't be directly observed. The social implications were revolutionary. For the first time in human history, it became possible to organize large groups of people around shared beliefs rather than just shared immediate needs. Religious systems, political hierarchies, and economic institutions all became possible once humans could conceive of abstract authorities and obligations that transcended face-to-face relationships. But this cognitive revolution came with costs that we're still grappling with today. The same mental flexibility that allowed humans to imagine complex social systems also made it possible to categorize other humans as fundamentally different, as members of outgroups who didn't deserve the same consideration as members of one's own community. The archaeological record from the post-Ice Age period shows increasing evidence of organised violence between human groups, not the small-scale conflicts that had occasionally erupted between competing bands of hunters, but systematic warfare involving coordinated attacks, defensive fortifications, and the deliberate targeting of entire communities. At the same time, within communities we begin to see the emergence of social stratification on a scale unknown during the Ice Age. Burial sites reveal dramatic differences in the treatment of the dead, with some individuals interred with vast quantities of valuable goods, while others were buried with nothing at all. Living sites show similar patterns, with some dwellings far larger and more elaborate than others. These changes weren't simply the result of some groups accumulating more resources than others. They reflected a fundamental shift in how humans thought about social relationships. The egalitarian ethos that had characterized most Ice Age societies, where leadership was situational and resources were shared according to need, was giving way to systems based on inherited status, accumulated wealth, and institutionalized authority. The transition was neither smooth nor inevitable. Many post-Ice Age societies experimented with different forms of organization, and the archaeological record shows numerous examples of communities that maintained relatively egalitarian structures even as they adopted agricultural technologies and settled lifestyles. But the overall trajectory was clear. The cognitive abilities that had allowed humans to survive the Ice Age were now being channeled into creating increasingly complex and hierarchical societies. The same mental flexibility that had once been used to track mammoth herds across vast territories was now being applied to managing agricultural surpluses, organizing labor forces, and maintaining control over large populations. Perhaps most significantly, humans were beginning to modify their environments on a scale that went far beyond anything seen during the Ice Age. Forest clearance for agriculture created entirely new landscapes. The domestication of animals led to the development of pastoral societies that transformed vast grasslands. River systems were diverted for irrigation, fundamentally altering regional hydrology. These environmental modifications weren't just practical adaptations. They were expressions of a new relationship between humans and the natural world, one based on the assumption that nature existed primarily as a resource to be exploited rather than a system to be understood and worked with. The psychological implications of this shift were profound. Ice Age humans had lived in a world where their survival depended on intimate knowledge of natural systems and careful attention to environmental feedback. Post-Ice Age humans increasingly lived in artificial environments of their own creation, insulated from the immediate consequences of their actions by layers of technology and social organization. This insulation made possible unprecedented achievements in art, science, and philosophy. But it also created a dangerous disconnect between human decision-making and ecological reality. For the first time in our species' history, it became possible for humans to make choices that seemed rational from a short-term social perspective, but were ultimately destructive from a long-term environmental perspective. The genetic evidence from this period reveals another fascinating dimension of the transformation. As human populations grew larger and more sedentary, they became subject to new forms of natural selection. Diseases that had been rare in small mobile hunting bands became major selective pressures in crowded agricultural communities. Genetic variants that provided resistance to infectious diseases spread rapidly through populations. At the same time, the physical demands of agricultural life selected for different traits than had been advantageous during the Ice Age. The lean, highly mobile physiques that had characterized Ice Age hunters gave way to more robust builds, better suited to repetitive agricultural labor. Digestive systems evolved to better process the grain-heavy diets that agriculture made possible. But perhaps most intriguingly, there's evidence that the intense social complexity of post-Ice Age societies was selecting for new forms of cognitive ability. Genetic variants associated with social cognition, language processing, and the ability to navigate complex hierarchical relationships appear to have been under strong positive selection during this period. In other words, the end of the Ice Age didn't just change how humans lived, it changed what humans were becoming, both culturally and biologically. The selection pressures that had shaped our species for hundreds of thousands of years were being replaced by entirely new pressures created by the artificial environments humans were constructing for themselves. This feedback loop between cultural innovation and biological evolution accelerated as post-Ice Age societies became more complex. Technologies that initially developed as solutions to immediate practical problems began taking on lives of their own, creating new challenges that required further innovations to address. The development of metallurgy, for example, began as a way to create more effective tools and weapons. But it also required new forms of social organization to coordinate mining, smelting, and distribution. These organizational innovations, in turn, made possible even more complex technologies, which required even more sophisticated social systems to manage. Within just a few thousand years of the Ice Age's end, human societies had become so complex that no individual could fully understand how they worked. The intimate, face-to-face relationships that had characterized Ice Age bands gave way to vast networks of strangers connected by abstract systems of exchange, authority, and belief. This transition represented perhaps the most dramatic transformation in the history of life on Earth. Never before had a single species so rapidly and completely altered both its own nature and the nature of the planet it inhabited. The cognitive abilities that had evolved to help small bands of humans survive in Ice Age environments were now being applied to challenges of unprecedented scale and complexity. Yet even as human societies became increasingly sophisticated, they remained dependent on the same basic biological and psychological systems that had evolved during hundreds of thousands of years of hunter-gatherer existence. The brains that were now grappling with abstract mathematics and complex social hierarchies were still essentially Ice Age brains, adapted for life in small groups facing immediate physical challenges. This mismatch between ancient psychology and modern challenges created tensions that continue to shape human behavior today. The same cognitive biases that had helped Ice Age humans make quick decisions in life or death situations often led post-Ice Age humans to make choices that were counterproductive in complex social environments. The tendency to favour immediate rewards over long-term benefits, for example, had been adaptive when resources were scarce and the future was uncertain. But in societies with surplus resources and complex planning requirements, this same tendency could lead to decisions that undermined long-term stability and prosperity. Similarly, the strong in-group preferences that had helped Ice Age bands maintain cohesion in hostile environments became sources of conflict and inequality in larger, more diverse societies. The same psychological mechanisms that had once promoted cooperation within small groups now often promoted competition and hostility between larger social categories. Understanding these deep evolutionary roots of human behavior became crucial for anyone trying to navigate the increasingly complex social landscapes that emerged in the millennia following the Ice Age. The most successful post-Ice Age societies were often those that found ways to channel ancient psychological tendencies toward constructive ends, rather than simply trying to suppress them. But perhaps the most remarkable aspect of this entire transformation was how quickly it occurred. In evolutionary terms, the transition from Ice Age hunter-gatherers to complex agricultural societies happened in the blink of an eye. The same species that had spent hundreds of thousands of years perfecting the skills needed to track mammoth herds across frozen tundra was suddenly building cities, developing writing systems, and creating works of art and architecture that still inspire awe today. This rapid transformation wasn't just a testament to human adaptability, it was evidence of something unprecedented in the history of life on Earth. The emergence of a form of evolution that operated not through genetic changes alone, but through the accumulation and transmission of cultural information across generations. The Ice Age had created the cognitive foundations for this cultural evolution by selecting for enhanced working memory, pattern recognition, and social learning abilities. But the end of the Ice Age provided the environmental conditions that allowed these abilities to be applied to entirely new domains, creating feedback loops between cultural innovation and social complexity that accelerated change at an unprecedented pace. The result was a species that had become, in a very real sense, the architects of its own evolution. No longer simply subject to the blind forces of natural selection, humans had developed the ability to consciously direct their own development through cultural choices and technological innovations. This power came with responsibilities that our Ice Age ancestors could never have imagined. The same abilities that made it possible to create civilizations also made it possible to destroy them. The same technologies that could support millions of people could also damage the environmental systems that all life depended on. As we'll see, learning to navigate these new responsibilities would become one of the defining challenges of human existence in the post-Ice Age world. The cognitive revolution that had begun in the frozen camps of mammoth hunters would ultimately determine not just the fate of our species, but the fate of the entire planet. The weight of that transformation still echoes in our bones today. Because what emerged from the melting ice wasn't just a new way of organising human societies. It was a new form of consciousness itself, one that could conceive of problems and solutions on scales that no Ice Age mind had ever needed to contemplate. Consider what it meant to be the first human who looked at a wild grass and imagined it growing in rows, not just gathering what nature provided, but actively reshaping the living world to serve human purposes. This wasn't simply a technological leap, it was a psychological revolution that required minds capable of thinking in abstractions that had no immediate physical reference. The archaeological evidence from sites like Abu Huraira in Syria, dating to around 13,000 years ago, reveals this transition in startling detail. In the earliest layers, we find the scattered remains of wild gazelle hunts and gathered plant foods, the familiar signature of mobile hunter-gatherer life. But in the upper layers, something unprecedented appears, the bones of the same gazelle species, but now showing signs of deliberate management. Young males culled at specific ages, females maintained in proportions that suggest selective breeding. These weren't wild animals being hunted, they were becoming something that had never existed before in Earth's history, domestic livestock. And the transformation wasn't happening to the animals alone. It was happening to the humans who were managing them. The daily routine of animal husbandry required forms of attention and planning that were fundamentally different from the episodic intensity of Ice Age hunting. Instead of the sharp focus needed to track a mammoth herd across dozens of miles, domestic animal management demanded consistent, repetitive attention to the small details that maintained health and productivity over months and years. This shift toward routine, systematic thinking had profound implications for human consciousness. The seasonal rhythms that had structured Ice Age life gave way to daily schedules of feeding, milking, and monitoring. Time itself became more granular, measured not just in the broad cycles of migration and weather, but in the incremental changes that marked the growth of crops and the maturation of livestock. But the most significant change was happening in how humans thought about causation. Ice Age minds had been exquisitely attuned to reading the immediate relationships between cause and effect in natural systems. The angle of animal tracks in mud revealed the direction and speed of movement. The colour of leaves indicated the nutritional content of plants. The behaviour of birds signalled changes in weather patterns. Agricultural thinking required a different kind of causal reasoning, one that could trace connections across much longer time periods and through much more complex chains of interaction. The decision to plant seeds in a particular location had to take into account soil quality, drainage patterns, sun exposure, and protection from animals. but it also had to consider factors that might not become relevant for months: the timing of rains, the likelihood of floods, the availability of labour for harvest. This expansion of causal thinking beyond immediate sensory experience was perhaps the most important cognitive development in human history. It made possible not just agriculture, but all the forms of long-term planning that would characterize complex societies: architecture that could last for generations, trade relationships that spanned continents, religious and philosophical systems that attempted to explain the entire structure of reality. The neurological evidence for this transformation is subtle but compelling. Brain scans of modern humans show that the neural networks involved in long-term planning and abstract reasoning are significantly more developed than those found in our closest primate relatives. But more intriguingly, these same networks show the greatest activity when people are engaged in the kinds of tasks that would have been central to early agricultural life: coordinating group activities, managing resources over time, and thinking about hypothetical future scenarios. This suggests that the cognitive abilities we now consider most distinctively human may have been shaped not by the dramatic challenges of Ice Age survival, but by the seemingly mundane requirements of managing domestic plants and animals. The mind that could envision the harvest while planting the seed was the same mind that would eventually conceive of mathematics, literature, and philosophy. But this cognitive evolution came with trade-offs that we're still grappling with today. The same mental flexibility that made abstract thinking possible also made it easier for humans to lose touch with the immediate, physical realities that had once constrained their behaviour. Ice Age humans couldn't ignore environmental feedback because their survival depended on constant attention to natural systems. But agricultural humans could create artificial environments that buffered them from the immediate consequences of their actions. For the first time in our species' history, it became possible to make decisions based on abstract principles rather than direct sensory experience. This abstraction was both liberating and dangerous. It made possible unprecedented achievements in art, science, and social organisation, but it also created the possibility of systematic errors in judgment, mistakes that could compound over time until they threatened the stability of entire civilizations. The collapse of early agricultural societies often followed a predictable pattern. Initial success led to population growth and territorial expansion. Increased population density put pressure on local resources. Technological solutions temporarily masked the underlying problems while creating new dependencies. Eventually, the accumulated stresses exceeded the system's capacity to adapt, leading to rapid social and economic collapse. This pattern repeated itself across different regions and time periods with such regularity that some archaeologists began to wonder whether there was something inherent in agricultural thinking that made such collapses inevitable. The same cognitive abilities that allowed humans to modify their environments also seemed to make them vulnerable to overconfidence in their ability to control complex systems. The genetic evidence from this period reveals another dimension of the transformation. As human populations became larger and more sedentary, they also became more genetically diverse within local areas, but more similar across large regions. The constant movement and mixing that had characterized Ice Age populations gave way to more stable, local communities that nonetheless maintained long-distance connections through trade and intermarriage. This changing pattern of gene flow had important implications for human evolution. Beneficial genetic variants could now spread rapidly across large populations through trade networks and cultural exchange. But harmful variants could also become fixed in isolated communities that lacked sufficient genetic diversity to buffer against their effects. The result was an acceleration of human evolution, but in directions that were increasingly influenced by cultural rather than purely environmental factors. Genetic variants that enhanced social cognition language processing, and the ability to digest agricultural foods spread rapidly through farming populations. Meanwhile, variants that had been adaptive for Ice Age lifestyles became less common or disappeared entirely. This coevolution between cultural and biological change created feedback loops that accelerated the pace of human transformation. Cultural innovations created new selective pressures that favoured particular genetic variants. These genetic changes, in turn, made possible new forms of cultural complexity, which created even stronger selective pressures in the same direction. Within just a few thousand years, the humans who had emerged from the Ice Age had become something qualitatively different from their ancestors, not just in their technologies or social organizations, but in their fundamental cognitive and biological architecture. They were becoming a species adapted not to any particular natural environment, but to the artificial environments they were creating for themselves. This self-directed evolution represented something unprecedented in the history of life on Earth. Never before had a species developed the ability to consciously modify its own evolutionary trajectory through cultural choices. The implications were staggering, both for human development and for the future of the planet itself. But perhaps the most remarkable aspect of this transformation was how unconscious it was for the people living through it. Each generation made small adaptations to changing circumstances, never fully aware that they were participating in a fundamental reorganization of human nature itself. The cognitive revolution that was reshaping our species happened gradually, through millions of individual decisions that seemed rational and necessary at the time. The farmers who first began selectively breeding plants and animals weren't trying to transform human consciousness. They were simply trying to ensure more reliable food supplies for their families. The craftsmen who developed new technologies weren't attempting to accelerate cultural evolution. They were solving immediate practical problems. The leaders who organized increasingly complex social systems weren't consciously directing human development. They were responding to the challenges created by larger populations and more sophisticated technologies. Yet the cumulative effect of all these individual choices was a transformation so profound that it altered not just human societies, but the entire biosphere. The planet that Ice Age humans had inhabited as one species among many was becoming a world increasingly shaped by human decisions and human values. This transition from environmental adaptation to environmental manipulation marked a fundamental threshold in Earth's history. For the first time in 4 billion years of evolution, a single species had developed the cognitive tools necessary to deliberately modify the conditions of its own existence. The question that remained was whether this unprecedented power would be used wisely. The answer to that question was still being written in the choices being made by the descendants of Ice Age survivors as they spread across the warming continents, carrying with them the cognitive gifts and burdens that had been forged in humanity's longest, coldest night. Each new settlement, each technological innovation, each social experiment was adding another line to a story whose ending remained uncertain. What was clear was that there could be no return to the world that had existed before the ice. The cognitive revolution that had begun in the frozen camps of mammoth hunters had unleashed forces that would continue to reshape both human nature and planetary systems for millennia to come. The species that had once survived by adapting to their environment had become a force of environmental change itself. And in that transformation lay both the greatest promise and the greatest peril that life on Earth had ever faced. The same minds that could conceive of agriculture and civilization could also conceive of their own destruction. The same technologies that could support millions of people could also damage the ecological systems that all life depended on. The same social innovations that could create unprecedented cooperation could also create unprecedented conflict. The legacy of the Ice Age wasn't just the cognitive abilities that had allowed humans to survive Earth's last great climate crisis, it was the responsibility that came with those abilities. The burden of conscious choice in a world where every decision could have consequences that stretched across generations and around the globe. Human consciousness had been transformed by ice and time into something unprecedented in Earth's history. What remained to be seen was what that consciousness would choose to create with the power it had been given. The transformation that began in the ice wasn't just changing individual human lives, it was reshaping the very fabric of existence on Earth. And nowhere was this more evident than in the relationship between humans and the other species that shared their warming world. During the Ice Age, humans had been part of a complex web of predator and prey relationships that had evolved over millions of years. Mammoth herds thundered across the steppes in migrations that followed routes established long before the first human footsteps. Cave lions stalked through forests that had known their presence for countless generations. Giant ground sloths browsed in woodlands where their ancestors had fed since the dawn of the Pleistocene. But as the glaciers retreated and human populations grew more sophisticated, this ancient balance began to shift in ways that would prove irreversible. The same cognitive abilities that allowed humans to plan agricultural cycles and coordinate complex social activities also made them devastatingly effective hunters when they chose to be. The archaeological evidence from this period tells a story that is both fascinating and sobering. Across North America, Australia, and parts of Europe, the end of the Ice Age coincided with the extinction of most large mammal species. Not gradually, over millions of years, as had happened in previous extinction events, but rapidly, within just a few thousand years as of human arrival or population expansion in each region. The timing is too precise to be coincidental. In Australia, giant kangaroos, enormous wombats, and predatory lizards the size of crocodiles all disappeared within a few thousand years of the first human settlements. In North America, mammoths, giant ground sloths, saber-toothed cats, and dozens of other large species vanished just as human populations were expanding across the continent. This wasn't simply a matter of humans hunting large animals to extinction, though that certainly played a role. It was something more subtle and more profound, the emergence of a species capable of modifying entire ecosystems through conscious decision-making. When humans began using fire as a landscape management tool, they weren't just clearing land for agriculture. They were fundamentally altering the vegetation patterns that supported complex food webs. When they began selectively hunting certain species while protecting others, they were reshaping predator-prey relationships that had been stable for millennia. When they began domesticating plants and animals, they were creating entirely new ecological relationships that had never existed in nature. The scale of this transformation becomes clear when we look at what happened to the grasslands that had supported Ice Age megafauna. The mammoth steppe, that vast ecosystem that had stretched from Western Europe to Alaska, didn't just disappear because the climate warmed. It disappeared because the large herbivores that had maintained it through their grazing patterns were no longer present in sufficient numbers. Without mammoths, woolly rhinoceros, and giant bison to keep the vegetation short and prevent tree growth, the grasslands began reverting to forest. This change happened remarkably quickly in geological terms, often within just a few centuries, and once the habitat was gone, any remaining large herbivores lost their food source and disappeared as well. The psychological implications of this transformation were as significant as the ecological ones. For the first time in human history, people were living in a world that was demonstrably different from the one their grandparents had known. The stories passed down through oral tradition spoke of animals that no longer existed, of landscapes that had vanished, of a time when the world had been fundamentally different. This created a new form of historical consciousness, an awareness that the present was not eternal, and that human actions could have consequences that extended far beyond individual lifespans. The same minds that could plan agricultural cycles began to grapple with the realization that they were living through changes that were reshaping the entire world. But perhaps most significantly, the end of the Ice Age marked the beginning of humanity's transition from being subject to natural selection to becoming an agent of selection for other species. The plants and animals that survived in the post-Ice Age world were increasingly those that could adapt to human-modified environments or that humans chose to protect and propagate. This transition accelerated as human societies became more complex and their environmental impact more extensive. The development of metallurgy led to more intensive mining, which altered local landscapes and water systems. The growth of cities created entirely artificial environments that nonetheless supported their own unique assemblages of plants and animals. The expansion of trade networks spread species far beyond their natural ranges, creating novel ecological communities that had never existed before. Within just a few millennia of the Ice Age's end, humans had become the dominant force shaping the evolution of life on Earth. Not through direct genetic manipulation, which would come much later, but through the systematic modification of environments and the conscious selection of which species would be allowed to thrive. This power came with responsibilities that most human societies were slow to recognize. The immediate benefits of environmental modification were obvious. More food, more security, more comfort. But the long-term consequences often took generations to become apparent, and by then the changes had become so deeply embedded in social and economic systems that reversing them seemed impossible. The civilizations that emerged in the millennia following the Ice Age can be understood as elaborate experiments in managing these new relationships between humans and the natural world. Some societies developed sophisticated systems of environmental stewardship that allowed them to maintain stability for thousands of years. Others pursued strategies of intensive exploitation that led to rapid growth followed by equally rapid collapse. But all of them were grappling with the same fundamental challenge: how to use the unprecedented cognitive abilities that had evolved during the Ice Age in ways that enhanced rather than undermined the long-term sustainability of human civilization. The genetic evidence from this period reveals that humans themselves were continuing to evolve in response to the new environments they were creating. Populations that had adopted agricultural lifestyles developed genetic variants that improved their ability to digest grains and dairy products. Urban populations evolved enhanced resistance to infectious diseases that thrived in crowded conditions. Groups that lived at high altitudes or in other challenging environments developed physiological adaptations that had never been needed during the Ice Age. But the most significant changes were happening not in human genes, but in human cultures. The cognitive abilities that had been forged during the Ice Age were being applied to increasingly abstract domains: mathematics, philosophy, art, religion, law. Each of these developments built on the foundational capacities for working memory, pattern recognition, and social learning that had been selected for during humanity's coldest millennia. The result was an explosion of cultural diversity that paralleled the biological diversity humans were simultaneously reducing through their environmental impact. Thousands of different languages, belief systems, artistic traditions, and social organizations emerged as human populations spread across the warming continents and adapted to local conditions. This cultural diversification created new forms of beauty and meaning that would have been impossible during the Ice Age. But it also created new sources of conflict as different human groups competed for resources and territory. The same cognitive abilities that made cooperation within groups more effective also made conflict between groups more devastating. The development of agriculture, metallurgy, and complex social organization gave some human societies enormous advantages over others. Groups that successfully adopted these innovations could support larger populations, develop more sophisticated technologies, and project power over greater distances. Those that didn't were often displaced, absorbed, or eliminated. This pattern of expansion and displacement accelerated as human societies became more complex and their technologies more powerful. By the end of the period we're examining, just a few thousand years after the Ice Age's end, human populations had spread to every habitable continent and were beginning to develop the technologies that would eventually allow them to modify the planet's climate itself. The transformation that had begun with small bands of Ice Age survivors learning to work together more effectively had become a force capable of reshaping the entire biosphere. The cognitive revolution that had started around campfires in frozen tundra was now driving changes that would be visible from space. Yet for all this dramatic transformation, the humans living through it remained fundamentally the same species that had survived the Ice Age. Their brains were still essentially Ice Age brains, adapted for life in small groups facing immediate physical challenges. Their emotional responses, social instincts, and cognitive biases were still those that had evolved during hundreds of thousands of years of hunter-gatherer existence. This mismatch between ancient psychology and modern challenges would become one of the defining features of human civilization. The same mental mechanisms that had promoted survival during the Ice Age often led to counterproductive behaviours in complex agricultural societies. The tendency to favour short-term rewards over long-term benefits, to trust in group members while being suspicious of outsiders, to make decisions based on emotional reactions rather than careful analysis, all of these had been adaptive during the Ice Age, but became sources of conflict and inefficiency in larger, more complex societies. Understanding this evolutionary mismatch became crucial for anyone trying to create stable, prosperous human communities. The most successful post-Ice Age societies were often those that found ways to channel ancient psychological tendencies toward constructive ends, rather than simply trying to suppress them. But perhaps the most remarkable aspect of this entire transformation was how it had emerged from such humble beginnings. The cognitive abilities that were now reshaping the planet had evolved not as grand adaptations to cosmic challenges, but as practical solutions to the immediate problems faced by small groups of humans trying to survive in a world of ice and scarcity. The working memory that could now encompass complex mathematical proofs had originally evolved to track the movements of animal herds across vast territories. The social learning abilities that were now transmitting sophisticated technologies across continents had originally developed to share information about food sources and survival techniques within small bands. The pattern recognition skills that were now revealing the hidden structures of the natural world had originally been used to read animal tracks in snow and mud. In every case, the magnificent achievements of post-Ice Age civilization had grown from the basic cognitive toolkit that had been assembled during humanity's struggle to survive Earth's last great climate crisis. The Ice Age hadn't just tested human adaptability, it had created the mental foundations for everything that would follow. And as we reach the end of our journey through this pivotal period in human history, perhaps the most important lesson is this. The same species that had once huddled around fires in Ice Age shelters, sharing stories and stone tools, had within just a few thousand years become capable of conscious, deliberate participation in its own evolution. The transformation from Ice Age survivors to agricultural civilizations wasn't just a change in lifestyle or technology, it was the emergence of a fundamentally new kind of consciousness, one capable of imagining futures that had never existed and working systematically to bring them into being. That consciousness, forged in ice and shaped by necessity, remains with us today. Every time we plan for tomorrow, cooperate with strangers, or try to understand the complex systems that surround us, we're using cognitive abilities that were refined during humanity's longest, coldest night. The Ice Age is over, but its legacy lives on in every human mind. We are all the descendants of those Ice Age survivors, carrying within us the same capacities for adaptation, cooperation, and innovation that allowed our ancestors to not just endure, but transform one of the most challenging periods in Earth's history. And perhaps that's the most hopeful message we can take from this ancient story. If a small population of Ice Age humans could develop the cognitive tools necessary to reshape an entire planet, then we who inherit those same tools might yet find ways to use them wisely, creating futures worthy of the extraordinary journey that brought us here. The last Ice Age ended 12,000 years ago, but the transformation it began in human consciousness continues today. We are still becoming, still evolving, still writing the next chapter of a story that began in firelight and continues beneath the stars. Human evolution didn't end when the ice melted. It simply changed direction, from adaptation to environment to adaptation through environment. And in that change lies both our greatest opportunity and our greatest responsibility as the inheritors of an Ice Age mind in a warming world. Thank you for taking this journey through deep time with me. Whether this helped you drift off to sleep, provided a companion for late night work, or simply offered a moment of wonder about our shared human story, I'm grateful you are here. If you found this exploration meaningful, consider sharing it with others who might appreciate this kind of thoughtful, evidence-based storytelling. And remember, we are all carriers of an ancient legacy, shaped by ice and time into something unprecedented in Earth's history. What we choose to do with that inheritance remains the most important question we face as a species. Sweet dreams, fellow descendants of the Ice Age. The story continues tomorrow. Where are you right now? Lying in bed scrolling through your phone? Sitting at your desk with coffee getting cold? Maybe you're walking, driving, cleaning, just letting your mind wander while your hands stay busy? Perfect. You're exactly where you need to be, because tonight we're going somewhere most documentaries never dare to venture. Not to the painted caves or the stone circles or the gleaming spear points that fill museum cases. We're going deeper into the invisible battlefield that raged inside every human body for tens of thousands of years before anyone knew what a germ was. This is Sleepless Homo Sapien, where we tell the slow, quiet stories that shaped us long before we had words to describe them. If you're here for explosions and conquests, you might want to find something else. But if you're curious about the hidden war that our ancestors fought every single day, the war they couldn't see or name, but somehow survived long enough for you to exist, then settle in. Dim the lights if you want. Let the modern world fade just a little, because we're about to step into a time when your immune system was your greatest weapon, and most battles were lost before anyone even knew they'd begun. This is the story of disease in the Stone Age, and if you find these deep dives into forgotten human struggles helpful, whether you use them to fall asleep, focus during work, or just think differently about where we came from, a like and subscribe helps more curious minds discover this quiet corner of the internet. No pressure, no algorithm panic, just a small way to say these stories matter. Now let's begin. Picture this. It's 15,000 years ago. You wake up in what we now call southern France, but back then it was just the world, unnamed and unmapped. The fire beside your shelter has burned down to embers. Your breath makes small clouds in the cold air. Your daughter, maybe 4 years old, is coughing. It started yesterday. Just a little tickle. Now it's deeper, wetter. Her forehead feels warm against your palm. You don't know what bacteria are. You've never heard the word virus. You have no concept of contagion, no understanding of how invisible enemies can leap from person to person, like sparks from a fire. All you know is that sometimes people get sick, and sometimes they don't get better. Sometimes the strongest hunter in your band will wake up weak and be dead before the next new moon. Sometimes a child who was laughing and running yesterday will be still and cold by morning. This was the reality for our ancestors. They lived in a world absolutely teeming with microscopic predators they couldn't see, couldn't understand, and couldn't fight directly. And yet somehow, against odds that should have wiped them out completely, they survived. Not just survived, they thrived enough to spread across every continent, to paint caves and carve bone flutes and tell stories around fires and eventually become us. How? How did people, with no knowledge of germs, no antibiotics, no hospitals, no concept of hygiene beyond what felt right, manage to navigate a microbial landscape so deadly that it makes modern pandemics look like minor inconveniences? The answer isn't just fascinating, it's the reason you're alive to hear it. The invisible war began the moment our ancestors started living differently. For millions of years, early hominins lived in small scattered groups, rarely staying in one place long enough for waste to accumulate or diseases to establish permanent footholds. They were nomadic, mobile, and most importantly, they were sparse. Pathogens need density to thrive. They need crowds, close contact, the kind of sustained transmission chains that only happen when lots of people live near each other for extended periods. But then something shifted. Around 20,000 years ago, some human groups began staying put longer. They started building more permanent shelters, creating seasonal camps they'd return to year after year. They began domesticating animals, bringing wild creatures into close, daily contact with human families. They started storing food, creating the surplus that would eventually lead to agriculture. And with every one of these seemingly positive changes, they opened new fronts in a war they didn't know they were fighting. The archaeological evidence paints a picture both subtle and devastating. In hunter-gatherer burial sites from before this transition, skeletal remains show relatively few signs of infectious disease. Bones are generally robust, teeth are strong. Growth patterns suggest adequate nutrition. These people faced dangers, certainly. Accidents, predators, the occasional violent encounter with neighbouring groups. But their skeletons don't scream of the kind of systemic, repeated assaults on human health that would come later. Then as settlements become more permanent and populations more dense, something changes in the bone record. We start seeing more signs of chronic infection, more evidence of childhood diseases that stunted growth, more skeletal markers of immune systems under constant siege. The transition isn't dramatic at first, it's subtle, statistical, the kind of change you only notice when you look at hundreds of skeletons across thousands of years. But it's there, written in calcium and phosphate, recorded in the very architecture of ancient bodies. What was happening? The answer lies in understanding how diseases actually work, how they spread, how they establish themselves in populations. Most infectious diseases are opportunistic. They're like fires waiting for the right conditions to ignite and spread. Too few people, and the pathogen burns out quickly, unable to find new hosts before its current victims either recover or die. Too much distance between groups, and diseases remain localized, contained by geography and isolation. But give a pathogen the right conditions, dense populations, close living quarters, poor sanitation, regular contact between groups, and suddenly what was once a minor threat becomes an existential crisis. This is exactly what began happening as human societies grew more complex, more settled, more interconnected. The first battleground was probably waste. Hunter-gatherer groups that moved frequently left their refuse behind, literally walking away from their own contamination. But settled groups had to live with their waste, and waste is a breeding ground for pathogens, contaminated water sources, accumulated garbage, human and animal excrement in close proximity to living spaces. These created perfect conditions for gastrointestinal diseases, parasitic infections, and bacterial contamination. We can see evidence of this in the archaeological record through something called coprolites, fossilized feces that preserve microscopic evidence of what our ancestors were dealing with. Stone Age coprolites from more settled sites show higher concentrations of parasitic worms, bacterial infections, and other microscopic invaders than those from fully nomadic groups. The settled lifestyle, even in its earliest forms, came with a microbial price, but waste was just the beginning. The real game changer was animals. For most of human evolution, our relationship with other species was straightforward. We hunted them. We avoided them. We occasionally competed with them for resources, but we didn't live with them. We didn't share our sleeping spaces, our food sources, our daily routines. Domestication changed everything. When humans began keeping dogs, goats, sheep, cattle, and pigs in close proximity, they unknowingly created bridges for diseases to jump between species. Most of the infectious diseases that have plagued human civilization for the past 10,000 years originally came from animals. Smallpox from cattle, influenza from pigs and birds, plague from rodents, tuberculosis from cattle, measles from cattle or dogs. The list goes on and on. Our Stone Age ancestors were the first humans to cross these dangerous thresholds, to live intimately with animals in ways their predecessors never had. And they paid for it in ways both visible and invisible. The visible costs show up in skeletal remains, evidence of chronic infections, stunted growth, shortened lifespans. The invisible costs are harder to measure, but equally real. The constant background stress of immune systems working over time. The energy diverted from growth and reproduction to fighting off microscopic invaders. And yet, paradoxically, this invisible war may have been one of the most important evolutionary pressures our species ever faced. Because the humans who survived weren't just lucky, they were selected. Their immune systems, their genetic resistance to common pathogens, their behavioural adaptations to living in disease-rich environments, all of these traits were tested and refined by millennia of microscopic combat. The result was a species uniquely equipped to handle infectious disease, at least compared to our pre-agricultural ancestors. We developed complex immune systems capable of remembering pathogens and mounting faster responses on re-exposure. We evolved behavioural instincts around cleanliness, food preparation, and social distancing during illness that helped limit disease transmission, even without understanding the underlying mechanisms. Most importantly, we developed cultural practices, rituals around death and illness, traditions of caring for the sick, methods of food storage, and preparation that reduced disease risk. These weren't based on scientific understanding. They were based on what worked, what kept more people alive, what communities that practiced them were more likely to survive and pass on their knowledge. The invisible war shaped us in ways we're still discovering. Recent genetic studies show that many of the immune system variants that help modern humans fight off infections were selected for during this crucial period when our ancestors first began living in permanent settlements with domesticated animals. The diseases that nearly destroyed them also gave them, and us, the tools to survive in a microbially dangerous world. But this is just the beginning of the story, because as human settlements grew larger and more complex, as trade networks developed and populations became more mobile, the invisible war intensified. New diseases emerged, old ones found new ways to spread, and human societies had to develop increasingly sophisticated strategies to survive in a world where the greatest threats were too small to see. What happened next would determine not just who lived and who died, but how human civilization itself would develop. The invisible war was about to become visible, written not just in bones and genes, but in the rise and fall of entire cultures, and our ancestors, armed with nothing but observation, trial and error, and a stubborn refusal to give up, were about to fight the most important battles in human history. The war they couldn't see was shaping everything they could. The most dangerous predator our ancestors ever faced wasn't the cave bear or the saber-toothed cat. It was something far smaller, far more patient, and infinitely more deadly. something that could hide in a drop of water, in a breath of air, in the warm touch between mother and child. The deadliest hunter in the Stone Age was invisible, and it was already inside the camp. Let's follow that invisible threat as it moved through a typical Paleolithic band. Picture a group of maybe 30 people, 3 families loosely related, following the seasonal migration of reindeer across what we now call northern Spain. It's 12,000 years ago. The ice is retreating, the world is warming, and life should be getting easier. But easier for humans means easier for everything else too, including the microscopic passengers that travel with them, patient and persistent as shadows. The first victim is always the most vulnerable, an infant, maybe 6 months old, whose immune system is still learning to recognize friend from foe. The child develops what we might call a fever, but to his mother, it's just a dangerous heat that won't break. She tries everything she knows: cool water on the forehead, certain leaves that the older women say help with sickness. She holds him close, skin to skin, trying to share her strength. She doesn't realize that her loving touch might be spreading the very thing that's killing him. Within days, the fever moves through the band like smoke through dry grass. The elderly feel it first, their weathered immune systems overwhelmed by something their bodies have never encountered before. Then the children. The adults hold out longer, but even they begin to weaken. What started as a single case becomes a crisis that threatens the survival of the entire group. This scene played out thousands of times across the Stone Age world. We know because we can read it in the bones, in the patterns of death and survival that tell stories no oral tradition ever preserved. Archaeological sites from this period sometimes reveal what researchers call catastrophic mortality events. Multiple burials clustered in time, ages skewing toward the very young and very old, the telltale signature of epidemic disease sweeping through small populations. But here's what's remarkable. Most of these groups didn't disappear entirely. Somehow some survived. The question is how? How did people with no understanding of contagion, no concept of quarantine, no knowledge of hygiene beyond what seemed practical, manage to develop strategies that kept them alive in a world trying to kill them? The answer lies in something we might call evolutionary wisdom. Not conscious knowledge, but the accumulated instincts and behaviours that emerge because the groups that practiced them were more likely to survive. These weren't planned strategies. They were the cultural equivalent of immune responses, developing slowly, unconsciously, through trial and error across countless generations. Take isolation behaviour. Modern humans have an instinctive response to illness that goes far deeper than rational thought. When we feel sick, we tend to withdraw, to seek quiet spaces, to avoid social contact. We assume this is just about feeling bad, about wanting to rest. But researchers now think this withdrawal response may be one of our oldest and most important survival mechanisms. Stone Age peoples seem to have developed elaborate versions of this instinct. Archaeological evidence suggests that in many hunter-gatherer societies, the sick were moved to separate shelters, cared for by specific individuals who took on the risk of exposure. These weren't hospitals in any modern sense, but they served the same basic function. They isolated the sick and limited the spread of disease through the larger group. We see hints of this in the burial record. Sometimes individuals who died during what appear to be disease episodes are buried apart from the main cemetery areas. Not abandoned, but separated, cared for in death as they were in life, but kept at a distance that might have helped protect the living. Even more sophisticated was the development of what we might call behavioural immunity. These were practices that reduced disease transmission without any understanding of germs or contagion. Food preparation rituals that involved cooking at high temperatures. Cleaning practices that removed contamination without knowing what contamination was. Social customs around touching, sharing, and proximity that minimized the spread of pathogens. Some of these practices survive in modern cultures as seemingly arbitrary taboos or traditions. The Jewish prohibition on mixing meat and dairy, for example, may have originated as a way to prevent food poisoning in an era before refrigeration. Islamic and Jewish restrictions on pork may reflect ancient recognition that these animals carried diseases dangerous to humans. Hindu concepts of ritual purity may preserve Stone Age intuitions about contamination and cleanliness. But the most important defense our ancestors developed wasn't behavioral at all. It was biological. The invisible war was fought not just between humans and pathogens, but between different versions of human genes. The individuals who survived epidemic diseases were those whose immune systems happened to be better equipped to fight them off. Their children inherited not just their tools and knowledge, but their genetic resistance to infection. This process, called pathogen-driven selection, may be one of the most powerful evolutionary forces our species has ever experienced. Diseases that killed most people in a population would spare those with certain genetic variants. Those survivors would have more children, and those children would carry the protective genes. Over hundreds of generations, human populations became increasingly resistant to the diseases that had once devastated them. We can see evidence of this process in modern human genetics. Many of the genes that control our immune responses show clear signs of having been under intense selective pressure in the recent evolutionary past. Variants that help fight off malaria, tuberculosis, and other infectious diseases are more common in populations that historically face those threats. The genetic landscape of human immunity is literally a map of the diseases our ancestors survived. But this biological arms race came with costs. Strong immune responses that could fight off deadly infections were also more likely to attack the body's own tissues, leading to autoimmune diseases. Genetic variants that provided resistance to one pathogen might increase vulnerability to others. The immune systems that kept our ancestors alive were powerful, but they were also dangerous, prone to overreaction and friendly fire. Some researchers think this may explain why modern humans are so susceptible to allergies and autoimmune conditions. Our immune systems were forged in a world full of deadly pathogens, calibrated to respond aggressively to any potential threat. In the relatively pathogen-free environment of modern developed countries, these hair-trigger responses may be doing more harm than good, attacking harmless substances like pollen or food proteins as if they were mortal enemies. The invisible war also shaped human behaviour in subtler ways. The universal human emotions of disgust and fear may have evolved partly as pathogen avoidance mechanisms. We instinctively recoil from rotting meat, stagnant water, bodily fluids, and other potential sources of contamination. These emotional responses feel automatic, hardwired, because they are. They're the psychological residue of tens of thousands of years of pathogen pressure, behavioural immune responses that kept our ancestors alive. Even our social instincts may bear the marks of ancient disease pressures. The human tendency to be suspicious of strangers, to form tight-knit in-groups, to be wary of outsiders. These traits make sense in a world where contact with unfamiliar people often meant exposure to unfamiliar diseases. Xenophobia and ethnocentrism, ugly as they are in modern contexts, may have originated as crude but effective public health measures. The archaeological record suggests that Stone Age peoples did indeed treat strangers differently during times of illness. Trade networks that normally connected distant groups would shut down during epidemic episodes. Seasonal gatherings that brought together multiple bands would be cancelled or postponed. Without understanding disease transmission, our ancestors nevertheless developed practices that limited it. But perhaps the most profound impact of the invisible war was on human cooperation itself. Fighting disease required not just individual resistance, but collective action. Someone had to care for the sick, even at personal risk. Someone had to maintain the group's knowledge, and traditions when the elders died. Someone had to make decisions about movement, resources, and contact with other groups when leadership was decimated by illness. The societies that survived were those that developed strong norms around mutual aid and collective responsibility. Archaeological evidence suggests that Stone Age groups invested enormous resources in caring for sick and disabled members. Skeletons from this period often show evidence of serious injuries or illnesses that would have required sustained care from others to survive. A broken leg that healed properly, a blind individual who lived to old age, a person with severe arthritis who was still buried with the tools of their trade. This wasn't altruism in the modern sense. It was evolutionary strategy. Groups that abandoned their sick members at the first sign of trouble were less likely to survive as coherent units. Those that developed strong caregiving traditions, that shared risk and resources even during crises, were more resilient in the face of both visible and invisible threats. The Invisible War was teaching our ancestors one of the most important lessons in human history. Individual survival wasn't enough. In a world full of threats too small to see and too complex to understand, only collective action, shared knowledge, and mutual support could ensure long-term survival. The diseases that nearly destroyed them were also forging them into something new, something more cooperative, more resilient, more human. But the war was far from over. As human groups grew larger and more connected, as they began to domesticate plants and animals, as they started living in permanent settlements, the invisible enemies evolved too. New diseases emerged from the growing intimacy between humans and their livestock. Old pathogens found new ways to spread through increasingly dense populations. The battlefront was about to shift in ways that would challenge every survival strategy our ancestors had developed. The next phase of the Invisible War would be fought not in small hunting bands scattered across empty landscapes, but in villages and towns where hundreds of people lived in close quarters, where waste accumulated faster than it could be cleaned, where domestic animals shared living space with human families. The stakes were about to get much higher, and the enemies much more dangerous. Human civilization itself was about to become both a weapon and a battlefield in the war against invisible death. The moment humans began to cluster together in something resembling permanent settlements, they unknowingly triggered an arms race with enemies they couldn't see. It wasn't the large predators that would determine who lived and who died in this new world. It was the smallest ones. And as human communities grew from scattered bands of 30 to villages of hundreds, the invisible battlefield expanded in ways that would have terrified our ancestors if they could have comprehended what was coming. Around 10,000 years ago, in the fertile valleys of the Near East, something unprecedented was happening. Humans were staying put, not just for a season or two, but for generations. They were building houses that would outlast their builders, digging storage pits that would hold grain through multiple winters, creating the first permanent human settlements in history. And with every stone they laid, every foundation they dug, every wall they raised, they were changing the rules of the Invisible War. The pathogens that had once burned through small hunting bands and then died out for lack of new hosts suddenly found themselves in paradise. Dense populations living in close quarters, sharing water sources, breathing each other's air, handling each other's waste. For a virus or bacteria, these early villages were like finding an endless buffet after millennia of scraping by on occasional meals. The skeletal evidence from this period tells a story that would be tragic if it weren't also triumphant. Bones from Neolithic settlements show dramatically higher rates of infectious disease than their hunter-gatherer predecessors. Childhood mortality spikes, growth stunting becomes common, dental abscesses, joint infections, and other signs of chronic illness appear in burial after burial. These people were paying a tremendous biological price for their new way of life, but they were also learning. Without understanding the microscopic mechanisms at work, early villagers began developing increasingly sophisticated responses to the disease pressures they faced. Archaeological evidence suggests they were experimenting with waste management systems, digging specialized pits for human refuse, creating drainage channels to direct contaminated water away from living areas. These weren't engineering marvels, but they were engineering, conscious, deliberate attempts to solve problems they could observe even if they couldn't understand their underlying causes. Food storage became a battleground in the invisible war. Surplus grain, the foundation of settled life, was also a perfect breeding ground for rodents, insects, and the diseases they carried. Early farmers had to learn through bitter experience how to build storage containers that kept out moisture, pests, and contamination. They developed techniques for drying, smoking, and preserving foods that reduced the risk of spoilage and illness. They created elaborate rituals around food preparation and consumption that, while couched in religious or cultural terms, served essential public health functions. The introduction of domestic animals into human settlements created entirely new categories of health risk. Cattle, pigs, sheep, and goats didn't just provide meat, milk, and materials. They also provided diseases. Tuberculosis jumped from cattle to humans. Influenza evolved from pigs and birds. Anthrax spread from livestock to their human caretakers. For the first time in human history, people were living in daily intimate contact with other species, sharing sleeping spaces, food sources, and bodily fluids with creatures whose microbial passengers had never before had regular access to human hosts. The archaeological record from early farming communities shows clear evidence of zoonotic disease transmission. Human skeletons display lesions characteristic of tuberculosis, a disease that requires sustained close contact to spread effectively. Childhood remains show signs of infections that match known livestock diseases. Even more telling, the patterns of disease in human populations begin to mirror those seen in domestic animal herds, suggesting shared pathogen pools. Yet somehow, these early farming communities not only survived but thrived. Population densities that should have been unsustainable given the disease load continue to grow. Villages that should have been wiped out by repeated epidemics persisted for centuries. How? The answer lies in understanding that the invisible war was forcing rapid evolution on both sides. As disease pressure increased, human populations were undergoing intense natural selection. The individuals who survived to reproduce weren't just lucky. They carried genetic variants that provided some protection against the pathogens they faced. Their children inherited not just their parents' tools and knowledge, but their disease resistance. This process was accelerated by the increased population density itself. In small hunter-gatherer bands, a favourable mutation might take hundreds of generations to spread through the population. In dense farming communities, beneficial genes could proliferate much more quickly. The same conditions that made disease transmission more efficient also made genetic adaptation more rapid. We can see evidence of this accelerated evolution in the genetic makeup of modern populations. People whose ancestors lived in areas with high disease loads for thousands of years carry different immune system variants than those whose ancestors remained in low-density, nomadic societies. European populations, descended from some of the earliest farming communities, show genetic adaptations to tuberculosis, smallpox, and other crowd diseases. African populations that lived with malaria for millennia evolved sickle cell, anemia, and other protective mutations. Asian populations developed resistance to different pathogen suites based on their particular disease environments. But genetic adaptation wasn't the only response. Human communities were also evolving culturally. developing increasingly sophisticated behavioral defenses against invisible threats. Burial practices became more elaborate, not just out of religious sentiment, but as ways to safely dispose of potentially infectious corpses. Food taboos emerged that happened to reduce disease transmission. Social customs developed around cleanliness, contact with strangers, and behaviour during illness. Some of these cultural innovations were remarkably sophisticated. Archaeological evidence suggests that some Neolithic communities developed primitive quarantine systems, isolating sick individuals in separate structures at the edge of settlements. They created specialised burial grounds for those who died during disease outbreaks, suggesting recognition that some deaths were different from others, more dangerous to the living. Trade networks, which connected distant communities and allowed for the exchange of goods and ideas, also became vectors for disease transmission. But early traders seem to have developed customs that reduced these risks. Seasonal trading posts where goods could be exchanged without direct contact, ritual purification ceremonies before entering new communities, waiting periods between arrival and commerce that might have served as informal quarantine measures. The invisible war was also changing the physical structure of human settlements. Villages began to show evidence of planning that went beyond simple convenience. Houses were arranged to maximise airflow and minimise waste accumulation. Water sources were protected from contamination. Storage areas were designed to reduce pest infiltration. These weren't conscious public health measures, but they served that function. Perhaps most importantly, settled life was forcing humans to develop new forms of social organisation that could survive repeated population crashes. Disease outbreaks that killed 30, 40, or even 50% of a community's members required robust systems for maintaining essential knowledge and skills. Communities had to develop ways to ensure that critical information about farming, tool-making, food storage, and other survival skills could survive the loss of their most experienced practitioners. This led to the emergence of more formal teaching traditions, apprenticeship systems, and cultural institutions dedicated to preserving and transmitting knowledge. The same population density that made disease transmission more efficient also made knowledge transmission more reliable. A craft technique or farming practice that might be lost forever in a small nomadic band could survive in a larger settled community, even if its original practitioners died. The invisible war was literally shaping human civilization. The need to survive in disease-rich environments was driving innovations in engineering, social organization, food production, and cultural transmission that would become the foundations of complex society. The pathogens that threatened to destroy early farming communities were also forcing them to become more sophisticated, more resilient, more capable of supporting larger populations. But this evolutionary arms race was far from over. As human communities grew larger and more interconnected, as trade networks expanded and populations became more mobile, new diseases would emerge, and old ones would find new ways to spread. The invisible enemies were evolving too, becoming more virulent, more transmissible, more deadly. The stage was being set for confrontations between humans and pathogens that would make the early struggles of Neolithic villages seem like minor skirmishes. Plagues that would topple empires, epidemics that would reshape continents. The invisible war that began in small hunting camps was about to become a force that would influence the rise and fall of civilizations. And through it all, in ways both visible and invisible, the microscopic enemies that had stalked humanity since the beginning were continuing to shape what we would become. The war against invisible death was writing itself into our genes, our cultures, our very conception of what it meant to be human. Every breath we take, every social custom we follow, every instinctive response to illness and contamination carries the echo of battles fought by ancestors who never knew their enemies had names. The invisible war continues still, patient and persistent as ever, waiting in the spaces between us, in the air we share, in the food we eat, and the animals we live beside. Our ancestors gave us the tools to fight it, written in blood and bone, and the hard-won wisdom of 100,000 generations. Whether we use those tools wisely may determine not just our survival, but our humanity itself. The strangest thing about the Invisible War wasn't how deadly it was was how it made our ancestors kinder. You wouldn't expect microscopic predators to teach lessons about compassion, but that's exactly what happened. Because when death could come from a breath, a touch, a shared meal, the communities that survived weren't the ones that abandoned their sick. They were the ones that learned to care for them. And that caring, born out of necessity, in a world full of invisible threats, may have been one of the most important innovations in human history. Let me paint you a picture from about 8,000 years ago. A small farming village in what we now call Turkey. Maybe 60 people, living in mud brick houses clustered around a central courtyard. Barley growing in neat rows beyond the settlement walls. Sheep and goats penned nearby, their bleating mixing with the sound of children playing and women grinding grain. Then the fever comes. It starts with one child, then spreads to his family, then beyond. Within days, half the village is burning with temperatures that won't break. The elderly start dying first, then the youngest children. In a hunter-gatherer band, this would be catastrophic. The survivors would scatter, abandoning the sick, fleeing to safer ground. But these people can't flee. Their lives are rooted here, literally. Their grain stores, their animals, their investment in this place. They have nowhere to go. So they do something unprecedented in the history of life on Earth. They stay, they organise, they create what we might recognise as the first hospitals, the first systematic approaches to caring for the sick during epidemic disease. The archaeological evidence for this is subtle, but unmistakable. In settlements from this period, we find structures that seem purpose-built for isolation and care. Small buildings at the edges of villages, separated from main living areas, but still connected by pathways. Inside these structures, we find the remains of fires that burned continuously, evidence of food preparation, signs of long-term occupation by people who are likely too sick to care for themselves. These weren't death houses where the sick were abandoned to die. They were care facilities where the ill were tended by others who risked their own lives to provide comfort and treatment. We know because we find the bones of both patients and caregivers in these spaces. People who died together while fighting the same invisible enemies. But here's what's remarkable. The communities that developed these early healthcare systems weren't just more compassionate, they were more successful. Settlements that show archaeological evidence of systematic care for the sick also show evidence of longer occupation, larger populations, more complex material culture. Taking care of each other wasn't just morally admirable, it was evolutionarily advantageous. Why? Because epidemic diseases don't just kill people randomly. They create predictable patterns of mortality that can devastate the social structure of a community. The very young die because their immune systems aren't fully developed. The elderly die because theirs are worn out. But the people in between, the adults in their prime reproductive and productive years, they're the ones most likely to survive if given proper care. A community that abandoned its sick members during an epidemic might avoid some immediate risk of contagion, but it would also lose crucial knowledge and skills. The elderly who died alone might have been the only ones who remembered how to predict weather patterns, when to plant specific crops, how to navigate trade relationships with neighbouring groups. The children who died untended might have been the future of the community, the ones who would carry its traditions and innovations forward. But communities that organised systematic care, that risked infection to tend their sick members, preserved more of their human capital. They kept their knowledge holders alive longer. They maintained social bonds during crisis. They demonstrated to their own members that the community would not abandon them in their moment of greatest need, creating powerful incentives for loyalty and cooperation. The invisible war was teaching our ancestors that in a world full of unseen threats, individual survival strategies weren't enough. Only collective action, mutual aid, and shared risk could ensure long-term community survival. The diseases that threatened to tear apart the social fabric were also forcing humans to weave it more tightly. This shows up in the material record in fascinating ways. Burial practices from early farming communities become increasingly elaborate and standardized. People who died during disease outbreaks receive the same careful treatment as those who died of old age or accidents. Grave goods become more common, suggesting that even in death, community members retain their social identities and connections. More telling still are the signs of care for the chronically ill and disabled. Skeletons from Neolithic settlements sometimes show evidence of severe injuries or congenital conditions that would have required sustained support from others to survive. A person with a badly healed broken leg who lived for years afterward. Someone with severe arthritis who nevertheless continued to work and contribute to community life. These aren't isolated cases. They represent a systematic change in how human communities responded to vulnerability. The invisible war was also changing how knowledge moved between people. In small mobile hunter-gatherer groups, information could be lost forever if its holder died unexpectedly. But in larger settled communities, critical knowledge had to be distributed more widely, passed on to multiple people who could preserve it even if disease struck down the original experts. This led to the development of more formal teaching traditions. Archaeological evidence suggests that craft specialization increased during this period, with specific individuals dedicating their lives to pottery, tool-making, textile production, and other skilled trades. But these specialists weren't hoarding their knowledge. The consistency of techniques across sites and time periods suggests they were actively teaching others, creating redundancy that could survive epidemic mortality. The same principle applied to medical knowledge. As disease pressures increased, communities began developing more sophisticated understanding of illness and treatment. Not scientific understanding in the modern sense, but practical knowledge about which plants seem to help with fevers, how to care for the seriously ill, what to do with bodies after death to prevent further contagion. This knowledge was too important to be held by just one or two individuals. It had to be distributed, shared, embedded in community practices that could survive the loss of any single person. The invisible war was forcing our ancestors to become better teachers, more systematic in their approach to knowledge preservation and transmission. We can see this in the increasing standardization of material culture during this period. Pottery styles become more uniform within regions, suggesting shared teaching traditions. Tool-making techniques show less variation, indicating more systematic apprenticeship systems. Even architectural styles become more consistent, as if communities were following increasingly formal building traditions passed down through generations. But perhaps the most profound change was in human emotional and social development. The constant presence of invisible threats, the regular experience of epidemic disease, the need to care for sick and dying community members. All of this was shaping how people thought about relationships, responsibility, and meaning. Archaeological evidence suggests that ritual and ceremonial activity increased dramatically during this period. Not just burial rituals, but elaborate ceremonies around healing, purification, and community bonding. These weren't just religious practices. They were psychological technologies, ways of processing trauma, maintaining social cohesion, and finding meaning in the face of inexplicable suffering. The figurines and artistic objects from early farming communities often show scenes of caregiving, healing, and mutual support. Images of people tending to others, sharing food, participating in group activities. This wasn't just artistic preference, it reflected the increasing importance of these behaviours in daily life. the way epidemic disease was forcing human communities to become more cooperative, more interdependent. The invisible war was literally rewiring human social instincts. The communities that survived weren't the ones with the strongest individuals or the best weapons. They were the ones with the most robust systems of mutual aid, the most effective strategies for preserving knowledge through crisis, the strongest commitments to caring for vulnerable members. These behavioural changes were being reinforced by genetic evolution. Individuals who are naturally more inclined toward cooperation, more willing to take risks to help others, more capable of forming strong social bonds, were more likely to survive in communities under constant disease pressure. Their children inherited not just their genes, but their social tendencies, creating feedback loops that made human communities increasingly sophisticated in their responses to collective threats. The result was something unprecedented in the history of life on Earth. A species that had evolved not just individual survival strategies, but collective ones. Communities that could maintain their knowledge, their social structures, and their cultural innovations even in the face of repeated catastrophic mortality events. The invisible war wasn't just killing our ancestors, it was teaching them to be human in ways they had never been before. The diseases that threatened to destroy early human communities were also forging them into something more resilient, more cooperative, more capable of surviving whatever invisible threats the future might hold. But the war was far from over. As human communities grew larger and more complex, as they developed trade networks that connected distant populations, as they began to domesticate new animals and crops, the invisible battlefield would expand in ways that would test every survival strategy they had developed. The next phase of the conflict would be fought not just between humans and pathogens, but between different human communities with different disease experiences, different genetic adaptations, different cultural responses to invisible threats. And when those communities met, when their separate evolutionary experiments collided, the results would reshape the entire human story. The caring that had emerged from necessity in small farming villages was about to be tested on a scale our ancestors could never have imagined. The invisible war that had taught them to tend their sick was about to teach them something even more challenging: how to remain human when the very act of contact with other humans could mean death. The most haunting moment in the invisible war came when two worlds collided, not continents crashing together in some geological catastrophe, but something far more subtle and infinitely more deadly. When communities that had spent thousands of years adapting to their own invisible enemies suddenly encountered communities with completely different microscopic passengers. These meetings, which should have been celebrations of human achievement, connections between distant peoples, often became apocalyptic events that could destroy entire civilizations in a matter of generations. Picture this scene, playing out countless times across the ancient world. A trading party approaches a distant village, carrying goods that have travelled hundreds of miles: obsidian from volcanic mountains, shells from distant seas, copper from remote valleys. They're welcomed with curiosity and celebration. Feasts are prepared, stories are shared. Children gather to stare at the strangers, with their exotic tools and unfamiliar accents, but hidden in that warm breath shared over evening fires, invisible in the touch of greeting hands, silent in the laughter that fills the night air, death is spreading. Not intentionally, not maliciously, just the inevitable consequence of two populations with different disease histories coming into contact for the first time. Within weeks, people who had never been seriously ill begin dying of fevers they have no name for. Within months, villages that had stood for centuries become ghost towns, their silent hearths slowly filling with wind-blown dust. This wasn't rare, this was the pattern. Every time human populations that had been separated for extended periods came back into contact, the invisible war intensified. The pathogens that had learned to coexist with one group found virgin territory in the other. Diseases that caused only mild illness in their original hosts became deadly plagues in new populations with no genetic or acquired resistance. The archaeological evidence for these collision events is written in the sudden appearance and disappearance of entire cultural traditions. Material cultures that flourished for centuries suddenly vanish from the record, replaced by completely different pottery styles, tool traditions, and settlement patterns. These aren't signs of conquest in the traditional sense. There are rarely signs of violence, no burned settlements, or mass graves filled with weapons. Instead, we see abandonment, emptiness, the quiet signature of populations simply ceasing to exist. But here's what makes this phase of the Invisible War so complex. The communities that survived these encounters weren't just lucky. They were the ones that had developed the most sophisticated strategies for managing disease transmission between groups. They had learned, through bitter experience, how to make contact with strangers without triggering catastrophic epidemics. Some of these strategies are preserved in the ethnographic record of historical hunter-gatherer and early farming societies. Elaborate protocols for approaching unfamiliar groups, ritual waiting periods before full contact was established, ceremonial exchanges that allowed for gradual exposure to new pathogens rather than sudden overwhelming contact. These weren't consciously designed as public health measures, but they served that function, reducing the risk of catastrophic disease transmission. Trade networks from this period show evidence of these protective protocols. Archaeological sites reveal trading posts that seem designed to facilitate exchange while minimizing direct contact between different populations. Neutral territories, where goods could be left and retrieved without face-to-face meetings. Seasonal gathering places that allowed for controlled, limited interaction between groups that normally lived far apart. These buffer zones and controlled contact systems represent some of the most sophisticated responses to disease risk in the pre-scientific world. Without understanding pathogens or transmission mechanisms, our ancestors were developing practices that accomplished the same goals as modern quarantine and disease surveillance systems. They were learning to navigate the invisible war not just within their own communities, but between communities. The genetic evidence tells an even more complex story. Populations that survived repeated contact with diverse groups show signs of having maintained much more genetic diversity in their immune system genes than isolated populations. This wasn't accident, it was selection in action. The communities that could handle exposure to a wide range of pathogens were those with the broadest spectrum of genetic resistance mechanisms. But genetic diversity alone wasn't enough. The populations that thrived in this interconnected world were also those that developed the most flexible cultural responses to disease. They maintained larger communities that could absorb population losses. They developed more robust systems for preserving knowledge through demographic crashes. They created more sophisticated care systems that could keep higher percentages of their sick members alive. Most importantly, they learned to balance the benefits of connection with the risks of contagion. Complete isolation might protect a community from foreign diseases, but it would also cut them off from trade goods, new technologies, genetic diversity, and the cultural innovations that came from contact with other groups. The communities that succeeded were those that figured out how to maintain connections while managing the microbial risks those connections created. This balancing act shows up in the archaeological record in fascinating ways. Settlement patterns from this period often show communities positioned to take advantage of trade routes while maintaining some distance from them. Villages located near rivers or mountain passes that facilitated long-distance travel, but set back far enough to control who entered and when. Architecture that includes specialized areas for receiving and processing goods from outside sources, separate from main living areas. The invisible war was teaching our ancestors one of the most important lessons in human history. That survival in an interconnected world required not just individual or community level strategies, but regional and even continental level coordination. Disease didn't respect territorial boundaries or cultural differences. Pathogens that emerged in one community could spread across vast networks, threatening populations that had no direct contact with the original source. This realization led to the development of some of the first large-scale human institutions. Not governments in the modern sense, but networks of communication and cooperation that could coordinate responses to invisible threats across multiple communities. Archaeological evidence suggests that information about disease outbreaks was being shared between settlements hundreds of miles apart, allowing distant communities to prepare for or avoid potential contagion. Religious and ceremonial networks may have served this function, creating regular gatherings where information about health conditions could be shared along with ritual activities. Trade guilds and merchant associations certainly played this role in later periods, developing protocols for safe travel and commerce that took disease risks into account. Even marriage networks between communities may have evolved partly as ways of sharing immunity and disease resistance across populations. The invisible war was forcing our ancestors to think beyond their immediate communities, to consider their health and survival as connected to the health and survival of groups they might never directly encounter. A disease outbreak in a community hundreds of miles away could threaten their own survival if it spread along trade routes or migration paths. Their own health decisions, their own responses to illness, could have consequences for distant populations they had never met. This interconnected thinking about invisible threats may have been one of the foundations of complex civilization itself. The need to coordinate responses to disease across multiple communities required the development of communication systems, leadership structures, and decision-making processes that could operate at scales much larger than individual settlements. The invisible war was teaching our ancestors to think and act collectively, not just within their own groups, but across entire regions. But this expanded scale of cooperation came with expanded risks. As trade networks grew larger and more complex, as populations became more mobile and interconnected, the potential for catastrophic pandemic events increased exponentially. A disease that might once have burned through a single community and died out could now spread across continents, following the very networks that had been created to enhance human cooperation and prosperity. The stage was being set for confrontations between humans and pathogens that would dwarf anything our ancestors had yet experienced. Plagues that would follow trade routes across Eurasia, decimating populations from the Atlantic to the Pacific. Epidemics that would arrive with explorers and conquerors, wiping out entire civilizations that had no resistance to foreign diseases. The invisible war that had begun in small hunting camps was about to become a global conflict that would reshape the demographic and cultural map of the entire planet. And yet through it all, the lessons learned in those early encounters between distant communities would remain relevant. The strategies developed for managing disease transmission across cultural boundaries, the institutions created for coordinating responses to invisible threats, the recognition that individual and community health were inseparably connected to the health of larger human networks. These insights, born from necessity in a world full of unseen enemies, would become essential tools for survival in an increasingly interconnected world. The invisible war was teaching our ancestors that in a world where microscopic threats could travel faster than any human messenger, survival depended not just on fighting diseases, but on fighting them together. The pathogens that threatened to divide and destroy human communities were also forcing them to develop the cooperative strategies that would become the foundation of everything we now call civilization. But the war was far from over. In fact, it was about to enter its most devastating phase. As human populations grew larger and denser, as agricultural systems became more intensive, as animals and humans lived in ever closer proximity, new diseases would emerge that would make all previous epidemics seem like minor skirmishes. The invisible enemies were evolving too, becoming more virulent, more transmissible, more deadly. The next chapter of the Invisible War would be written not just in the bones of the dead, but in the rise and fall of empires, the movement of armies, the collapse of trade networks, and the reshaping of entire continents. The microscopic predators that had stalked humanity since its earliest days were about to prove that they were still the most dangerous enemies our species had ever faced. And in the end, the question that would determine the future of human civilization was not whether we could defeat these invisible enemies, but whether we could learn to live with them, to adapt to their presence, to build societies resilient enough to survive their periodic assaults. The invisible war that had shaped our biology, our behaviour, our very conception of what it meant to be human, was about to become the defining challenge of the civilized world. The ancestors who had learned to care for their sick, to coordinate responses across communities, to balance connection with protection, had given their descendants the tools they would need for the battles ahead. Whether those tools would be enough remained to be seen. The invisible war continued, patient and persistent as ever, waiting in the spaces between us, ready to test every assumption about human progress, every strategy for collective survival, every hope that we had finally learned to master the microscopic world that had mastered us for so long. The war our ancestors couldn't see was about to become visible in ways that would change everything. And in the end, that war never really ended. It just changed theatres, changed tactics, learned to hide in new places. The microscopic predators that had stalked our ancestors through ice ages and farming revolutions, through the first villages and the first trade routes, they didn't disappear when we invented writing or built cities or discovered antibiotics. They adapted, they waited, they evolved alongside us, patient as stone, persistent as gravity. Right now, as you listen to this, billions of invisible passengers are travelling with you, in your gut, on your skin, in the air you breathe. Most of them are harmless, some are even helpful, but others are simply biding their time. The same bacterial lineages that killed Neolithic farmers are still with us, still probing for weaknesses in our defences. The viral families that swept through Stone Age camps are still circulating, still mutating, still searching for new ways to slip past our immune systems. The difference is that now we can see them. We can name them, track them, sometimes even predict their movements. But seeing the enemy doesn't always mean we can defeat it. The COVID-19 pandemic reminded us, in the starkest possible terms, that we are still fighting the same invisible war our ancestors fought, still struggling with the same fundamental challenges. How do you balance connection with protection? How do you care for the vulnerable without endangering the healthy? How do you maintain social cohesion when contact itself becomes dangerous? The answers our Stone Age ancestors developed, slowly and painfully over tens of thousands of years, are still with us, written into our genes, embedded in our instincts, preserved in cultural practices we follow without thinking. The disgust response that makes you recoil from spoiled food. The social distancing that happens naturally when someone is visibly ill. The urge to wash your hands, to avoid crowds during disease outbreaks, to care for sick family members despite the risk to yourself. These aren't modern innovations. They're ancient wisdom, tested by millennia of invisible warfare, refined by countless generations of humans who survived long enough to pass them on. The same cooperative instincts that helped Neolithic communities organise care for their sick members drove the development of modern hospitals. The same long-distance communication networks that warned Stone Age settlements about approaching epidemics evolved into our global disease surveillance systems. But perhaps the most important lesson from the invisible war is also the most uncomfortable one. That progress isn't always progressive, that every advance in human civilization, every step toward greater complexity and connection, also creates new opportunities for our microscopic enemies. Agriculture gave us food security, but also zoonotic diseases. Cities gave us culture and commerce, but also epidemic transmission. Global trade networks give us prosperity and connection, but also pandemic risk. The invisible war taught our ancestors that survival isn't about defeating every threat, but about building resilience in the face of threats that can never be completely eliminated. They learned to live with uncertainty, to prepare for catastrophes they couldn't predict, to maintain hope in the face of invisible enemies they couldn't understand. And maybe that's the real gift they left us. Not just the genetic resistance to ancient diseases, not just the cultural practices that reduce transmission risk, but the deeper wisdom that comes from accepting our place in a world full of unseen forces beyond our control. The knowledge that individual survival depends on collective action. That caring for others is not just morally right, but evolutionarily essential. That the price of connection is vulnerability, but the cost of isolation is extinction. The bones in the ground tell us that our ancestors paid a terrible price for the lives we now live. Shorter lifespans, chronic illness, childhood mortality rates that would break our hearts. But they also tell us something else, that humans can adapt to almost anything, survive almost any catastrophe, find ways to maintain meaning and connection, even in the face of incomprehensible loss. The invisible war is still being fought, in laboratories and hospitals, in policy meetings and research papers, in the daily choices we make about how to live together safely in an interconnected world. The enemies have names now. We understand their mechanisms, their life cycles, their vulnerabilities, but the fundamental challenge remains the same. How do we remain human while fighting an inhuman threat? Our ancestors, those Stone Age survivors who learned to care for their sick and coordinate their responses and balance risk with connection, they didn't leave us a perfect world. They left us something more valuable, a species tough enough to survive the invisible war, wise enough to learn from it, and stubborn enough to keep fighting it, one generation at a time. So the next time you wash your hands, or avoid someone who's coughing, or stay home when you're feeling sick, or get a vaccination, or simply choose to help someone who's vulnerable, remember that you're carrying forward a tradition that stretches back to the very dawn of human civilization. You're a warrior in the same invisible war your ancestors fought, armed with better weapons, but facing the same fundamental challenge. The war they couldn't see shaped everything they became, and everything they became shaped everything we are. The battle continues, patient and persistent as ever, written in our DNA and whispered in our instincts, reminding us that we are still, and will always be, creatures forged in the crucible of invisible conflict. The Stone Age ended, but the war never did. It just taught us to fight smarter. And maybe, if we're very lucky and very wise, that will be enough.